In this lesson, we're going to talk about graphing tangent and cotangent. All right, so in the last lesson, we talked about how to sketch the graphs for sine and cosine, and we found that the process is really not that bad. The main thing to understand when you're in this section is that you are not expected to make a perfect graph. You're just expected to know the key information and how you could sketch the graph if you had to. Generally speaking, we're always going to use computer software, either something that's online or a graphing calculator like a TI-83 to sketch our graphs. So with that being said, let's go through how to sketch the graph for tangent and cotangent. We're going to start with a different period. So basically we know that the period for sine and cosine is 2 pi. But when you work with tangent and cotangent, you need to know that the period is now going to be pi. That's extremely important, especially when we get to solving trigonometric equations. So something like the tangent of x is going to be equal to the tangent of x plus pi n, where n is any integer, and we would also say that x is a member of the domain. Remember that when you work with tangent, you have places where it's undefined. Then we have cotangent of x is equal to the cotangent of this x plus pi n, again, where n is any integer, and x is a member of the domain. So let me just quickly demonstrate that the period for tangent and also cotangent is going to be pi. You can show this with identities, but we haven't gotten that far yet. First off, I'm just going to pick something like pi over 6 for the angle, so this guy right there. And you know that if you want the tangent of pi over 6, you can find it as the sine of pi over 6 divided by the cosine of pi over 6. In other words, we should know that the tangent of x is equal to your sine of x over your cosine of x. So the tangent of pi over 6 is going to be equal to the sine of pi over 6, and then this would be divided by the cosine of pi over 6. So what would this be equal to? We know that the sine of pi over 6, again, that's going to be given by the y-coordinate right there, so that's 1/2. So let's write that. How do we divide fractions? We multiply by the reciprocal, so this is times. You would have the cosine of pi over 6, that's square root of 3 over 2, but you're going to find the reciprocal of that. So this is going to be times 2 over the square root of 3. And then basically the 2's are going to cancel. And let's say that this is 1 over the square root of 3. We want to rationalize the denominator here. So times the square root of 3 over the square root of 3. So this equals the square root of 3 over 3. So this is the square root of 3 over 3. Now I want you to notice that if you add pi, or you could say if you rotate by pi, so I'm going to come over here into quadrant 3, and we're going to be at 7 pi over 6. Now, I want you to think about if I found the tangent, so the tangent of 7 pi over 6, what would I get? Well, you're going to find that you're going to get that same square root of 3 over 3. And the reason for that is you're dividing in terms of absolute values the same numbers. It's just that now you're going to be dividing a negative by a negative, which is also going to give you a positive. So in other words, this is going to turn into your sine value is negative 1/2, and then divided by your cosine value, which is negative square root of 3 over 2. We're going to, again, multiply by the reciprocal. So let's go negative. We're going to go 2 over the square root of 3. And so the negative times the negative will give you a positive. The 2's will cancel. So this would end up being 1 over the square root of 3, which we know if we rationalize the denominator, that's going to be the square root of 3 over 3. So you can see that the tangent of pi over 6 and the tangent of 7 pi over 6, that's the same. So that's one way you can demonstrate this. I'll show you with some other ones, just so you can see the stuff in quadrant 2 and 4. So that's where tangent is negative. So let's say you pick something like, let's say 2 pi over 3. So that guy right there. And that color doesn't show up so well, so let me do that like that. And again, if you add pi to this, so if you add pi, you're going to come into quadrant 4, and you're going to be at this 5 pi over 3. So it should be true that the tangent of 2 pi over 3 is equal to the tangent of 5 pi over 3, because again, I added pi. Every time I add pi, I'm coming back to the same tangent value. So let's just try that real quick. So we have the tangent of 2 pi over 3. That would be equal to the sine of 2 pi over 3, which is the square root of 3 over 2, and then divided by the cosine of 2 pi over 3, which is negative 1/2. So I'm going to multiply by the reciprocal, so times 2 over negative 1, and of course the 2's are going to cancel, and you have square root of 3 over negative 1. Let's just say that's the negative of the square root of 3. Then if I come down here to 5 pi over 3, again, if I look for the tangent of 5 pi over 3, it's going to be the same thing. I'm going to be dividing opposites. Here it was basically a positive sine value divided by a negative cosine value. But here it's going to be a negative sine value divided by a positive cosine value. Well, we know if we have a positive divided by a negative or a negative divided by a positive, I'm going to get a negative. So that's what's happening here. So this is just going to be my negative square root of 3 over 2. That's the sine value here, divided by the cosine value, which is positive 1/2. So again, I'm going to multiply by the reciprocal, so times 2 over 1. And let's go ahead and cancel this with this. And so you get negative square root of 3. So hopefully that gives you a little bit of insight into why the period is going to be pi. All right, so what we're going to do now is just look at the basic graph for tangent. We're going to do this by grabbing some ordered pairs and just sketching this guy from negative pi over 2 to pi over 2, with both of those guys being excluded. Before I show you the graph, I want to cover a few things that basically cause a lot of confusion when you first see these graphs. The first thing is we should remember that when we see a negative angle, we're rotating clockwise. In other words, something like negative pi over 2, that means I'm starting here and I'm rotating clockwise. So it's going to be this guy right here. It would be coterminal with 3 pi over 2. So this is negative pi over 2. Now, why does it say that it's undefined here? We know that the tangent of x is equal to, we have the sine of x over the cosine of x. Well, if I want the tangent of negative pi over 2, that would be equal to the sine of negative pi over 2 over the cosine of negative pi over 2. Since this negative pi over 2 is coterminal with 3 pi over 2, we could just take the value for sine and cosine from this guy right here. And so basically, you could say that this is equal to the sine of negative pi over 2, well, that's negative 1. And then the cosine of negative pi over 2, well, that's 0. What do we know about division by 0? It's undefined. So basically, you stop at this point and you would say that this is undefined. Undefined. So this would always be true whenever the cosine value is 0. So basically, this is going to happen at pi over 2, then 3 pi over 2, then 5 pi over 2, 7 pi over 2, 9 pi over 2, so on and so forth. But also you have to consider that would happen at negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, so on and so forth. So a lot of books will cover this by saying that this guy is going to be undefined at odd multiples of pi over 2. So that's a good way to remember it. You could also write it as, if you want to do it this way, you could say that it's undefined at pi over 2, so this guy right here, plus pi n, where n is any integer. So basically, if it's a positive integer, then I'm rotating counterclockwise. So let's say I add pi, that's going to put me right here at 3 pi over 2. And if I add pi again, then it'd be at 5 pi over 2, then 7 pi over 2, so on and so forth. If n was a negative integer, well then basically now I have a clockwise rotation. So let's say I subtract pi, and I rotate clockwise like this, well now I'm not at 3 pi over 2, I'm going to be at negative pi over 2. And if I do that again and subtract away another pi, well now I'm going to be at negative 3 pi over 2, and so on and so forth. So all of those places it's going to be undefined because we're going to have a cosine value of 0, and division by 0 is undefined. Now the other thing you need to think about is that this guy is going to be 0 when the sine value is 0 and the cosine value is not 0. So something like, let's say, at 0, you have a sine value of 0, and the cosine value is 1. Then at pi, you have a sine value of 0, and a cosine value of negative 1. So basically for this, you could say that the tangent value is going to be 0 at pi n, where n is any integer. In other words, you could start here, and you could add pi, and you would get to pi. You could add pi again, and you would get to 2 pi, and then 3 pi, and then 4 pi, so on and so forth. And also, if you wanted to start here and rotate clockwise, so if you wanted to subtract pi away, well, now I'm going to be at negative pi. Then if I do that again, I'm going to be at negative 2 pi, then negative 3 pi, so on and so forth. So basically, that's where you're going to have a tangent value of 0, or you could say where your x-intercept's going to be. And you can see on the table that we've made that we do have this 0, 0. Okay, so let's look at a basic sketch for y equals tangent of x. So just using those points that we just had in our little table. So you have something like negative pi over 3, comma, negative square root of 3. So that would be this point right here. Then you have negative pi over 4, comma, negative 1. So that'd be this point right here. So this point is actually one we're going to focus on. it'll be important for us later on. Then we have negative pi over 6, comma, negative square root of 3 over 3. So that's this point right here. Then we have our 0, comma 0. So that's our x-intercept. And we'll focus on that one later on. Then you have your pi over 6, comma, square root of 3 over 3. Then you have your pi over 4, comma 1. Again, this is one we're going to focus on. And then we have our pi over 3, comma, square root of 3. So that's going to be this guy right there. So one of the things to focus on here is you do have a vertical asymptote at this negative pi over 2 and then also pi over 2. And that's being created because, again, at negative pi over 2 and pi over 2, you have division by 0, which is undefined. So we've seen this previously in our course. When we look at something like y equals 1 over x, well, we know that if you plugged in a 0 for x there, this is undefined. So if you look at the graph of that, you're going to end up with a vertical asymptote at x equals 0. So here, when you have y equals the tangent of x, which you could really write as the sine of x, so the sine of x over the cosine of x to make it more clear. Well, again, where this is 0, at negative pi over 2 or pi over 2, something like that, 3 pi over 2, 5 pi over 2, 7 pi over 2, so on and so forth, well, you're getting division by 0, so you're getting these vertical asymptotes. Now, when you think about the behavior, as this guy right here approaches pi over 2 coming from the left. So coming from the left, basically as we approach this x value of pi over 2, this guy is going to increase without bound, as they say, so approach positive infinity. So I have another little table for you. A lot of books will show this. So basically at an x value of 0, we get a y value of 0. At pi over 6, you get about 0.58. That's just approximating square root of 3 over 3. At pi over 4, you get 1. At pi over 3, you get about 1.73. That's approximating the square root of 3. And then we have 1.5 is about 14.10. 1.53 is about 24.50. 1.57 is about 1,255.77. And then this 1.5707 is about 10,381.33. And then notice that as you get really close to pi over 2, so 1.570796, you get 3,060,023.31. So you can get as close to this as you want, you just can't touch it. When you actually get to pi over 2, you're going to get undefined. But as you get closer and closer to it, this number is going to get larger and larger. So again, it's going to approach positive infinity, or what they'll say is increase without bound. Now, similarly, as you approach negative pi over 2, coming from the right, this guy is going to decrease without bound. So basically, it's going to approach negative infinity. All right, so just like we saw with graphing sine or cosine, after we did one cycle of the graph, we were able to continue that to the left or to the right as much as we wanted. So here I have y equals tangent of x. So I've extended this to the left and to the right a little bit, just so you can see a little bit more. So basically, this is what we graphed already. So from negative pi over 2 to pi over 2, we see that we have a vertical asymptote at negative pi over 2, and then also another one at pi over 2. Those are what we call consecutive vertical asymptotes. So when you graph a variation of y equals tangent of x, you're going to first find those guys. I'll tell you how to do that in a moment. And then basically you have these 3 points. So this one right here is at a quarter of the way through. And let me just label this as a for right now. So a, let's just say that's negative pi over 4, comma negative 1. That's definitely something you want to memorize. Then let's call this b. This is going to be the halfway point, or the midway as a lot of books call it. That's your x-intercept, so that's 0, comma 0. And then let's call this point c. So that's 3/4 of the way through. So basically that point is pi over 4, comma 1. So you can use these points to basically graph any variation of y equals tangent of x. If you want these points here or wherever it is, if you just want this one right here, remember the period for tangent is pi. So I could take the x value here. Let's just call this point D. Let's call this point E. And let's call this point F. So if I wanted those, let's just go ahead and say that for point D, well, the y value is going to be the same. All I have to do is add pi to the x value. So negative pi over 4, plus pi, so 4 pi over 4 to have a common denominator, and that's going to be 3 pi over 4. So this would be 3 pi over 4, and then comma negative 1. And then for E, I know that basically I would just take 0 and add pi, so that would be pi, comma, 0, y coordinate staying the same. And then this is going to be for F. Again, I'm just going to take this pi over 4, so pi over 4. I'm going to add pi, so 4 pi over 4, so that's 5 pi over 4. And then basically, you're going to have the same y coordinate, so it's still going to be 1. And you can basically use that process to extend the graph to the left or to the right as much as you want. All right, so just some information that you need to know. So for the tangent function, the domain contains all real numbers except odd multiples of pi over 2. Some books will write that as pi over 2 plus pi n, where n is an integer. So basically it's just telling you things like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. You could also have negative pi over 2, negative 3 pi over 2, so on and so forth. We have f of x is equal to tangent of x. You could also write y equals tangent of x is discontinuous at odd multiples of pi over 2. So basically we've seen that the graph contains vertical asymptotes at those values. The x-intercepts are of the form x equals pi n, where n is an integer. We know that that's because that's where the sign values are 0, and 0 divided by something that's not 0 gives you 0, so that's why that occurs. The x-intercept occurs at half of the way between consecutive vertical asymptotes. So if we're using y equals tangent of x over that interval that we talked about, so from negative pi over 2 to pi over 2, with both being excluded, that's going to occur at 0, 0. Then we have our point on the graph that's a fourth of the way between consecutive vertical asymptotes. This is going to have a y-coordinate of -1. So again, using that example, y equals tangent of x over the interval from negative pi over 2 to pi over 2, both excluded. We have that negative pi over 4, comma -1, and then the point on the graph 3/4 of the way between consecutive vertical asymptotes has a y-coordinate of 1. So again, using y equals tangent of x over that interval, negative pi over 2 to pi over 2, both being excluded, we have that pi over 4, comma 1. So we already know that the period is pi, and then there are no minimum or maximum values. So that's important. We saw that the range is from negative infinity to positive infinity. So that tells us that the graph has no amplitude. So that's important because you might get that on your test. It might ask you for the amplitude. Remember that when you think about the amplitude, we learned in the last lesson when we were graphing sine and cosine, that's half the difference between the maximum and minimum values. Well, here again, there are no minimum or maximum values, so you're not going to have an amplitude here. Then we can also say the graph is symmetric with respect to the origin. Remember that tells us we have an odd function. So the tangent of negative x is equal to the negative of the tangent of x for all x in the domain. Again, f of x equals the tangent of x is an odd function. All right, let's talk about the steps involved with graphing the tangent function. So what I'm going to do is give you a simple model here. And then if we get something that's a little bit more challenging, we can just modify our steps. So the first thing is we have y equals a times the tangent of bx minus c. And we're specifically going to say here that b, which is the coefficient of x, is greater than 0. Of course, we'll see scenarios where b is negative, and I'll show you how to deal with that with identities. For right now, let's go ahead and talk about the period. So what is the period? Again, when we think about this from our sine and cosine lesson, we know that if we had something like y equals the sine of bx, well, the period here, so the period here, was the standard period for sine, which is 2 pi, divided by b. Well, it's a similar thought process here. When you have y equals the tangent of x, the standard period is now pi. Not 2 pi, but pi. So let me put that off to the side. So y equals the tangent of x. The period is pi. So we know that. Well, here, the period for this guy right here, because you have b that's multiplying x, it's going to be pi over b. Now, I have a little sample illustration here to go through the procedure. So basically, the first thing you're going to do, you're going to find these two consecutive vertical asymptotes. And the way you do that is you go back to, again, y equals the tangent of x. We know that we generally graph one cycle from negative pi over 2 to pi over 2, with both being excluded. So you have x equals negative pi over 2, and you have x equals pi over 2. So you could say that one cycle occurs where x is greater than negative pi over 2 and less than pi over 2. So this negative pi over 2 and pi over 2, those are consecutive vertical asymptotes. Now, we don't have an argument of x, we have an argument of bx minus c. So we just have to adjust this. Let me get rid of this real quick. We're going to use the same thought process, though. We're going to say that we're going to do one cycle where bx minus c is greater than negative pi over 2 and less than pi over 2. And we can find the vertical asymptotes by saying that bx minus c is equal to negative pi over 2. So that would be one of them. We'll put and bx minus c is equal to pi over 2. So that would give you this guy and this guy. So the two consecutive vertical asymptotes that you're looking for. Once you have that, you need to find these 3 points. So you're going to have one that's a quarter of the way, halfway, and 3/4 of the way. The way you do that is you find your quarter period. just like we did with sine and cosine. And so basically, if the period is pi over b, well, you can multiply that by a fourth, and you could say that the quarter period is going to be pi over 4b. So you take your leftmost vertical asymptote, so that's x equals some number. You take that value and you add pi over 4b to that, and you're going to get the x value for the quarter of the way point. Then you add the quarter period, you get the halfway point. Then you add the quarter period, you get the 3/4 of the way point, and you could add a quarter period to get the next vertical asymptote if you wanted to, but again, you should already know what that is because you already set up those two equations. So the main thing is that you just have to find the x values there. The y values are very easy to find. You can just use the fact that at a quarter of the way through, the y coordinate is negative a. So whatever this is, it's the negative of it. Halfway through, it's going to be 0, and then 3/4 of the way through is just going to be a. Again, going back to what we saw earlier when we did y equals the tangent of x, remember I told you to memorize these 3 points. You have negative pi over 4, comma, negative 1. Well, you could put a 1 here if you want for clarity. Well, it's the negative of 1. That's how you get that y coordinate. Then you have another point, which is 0, 0. That's just your x-intercept. And then you have another point, which is pi over 4, comma, positive 1. Okay, so positive 1 there. So I would just memorize those 3 points from this basic tangent function. If you do that, you're going to be good to go with any graph that you come across. All right, let's take a look at an example with the tangent function. So we have f of x equals 2, and then tangent of 2x plus 2 pi over 3, and then plus 1. So what I'm going to do is just use the procedure that we just talked about. There's alternative approaches. When I get done with this problem, I'll show you another way that you could do it. I'll just do a few points using graphing transformations only. The first thing is to think back to what we talked about a moment ago. If we're graphing something like y equals the tangent of x, generally speaking, if you're graphing that over one period, or if you say you want to graph one cycle of this guy, well, we know that we're going to do x is greater than negative pi over 2 and less than pi over 2. We know there's a vertical asymptote at negative pi over 2 and also at pi over 2 because, again, the tangent of negative pi over 2 and the tangent of pi over 2 is going to be undefined because we'd have division by 0. So what you want to do is set up an inequality here. The argument is not x like we have here. The argument is 2x plus 2 pi over 3. So this guy right here just gets plugged in for this right here. So you're going to set up the inequality. Let me get rid of this. Where you say 2x plus 2 pi over 3 is greater than negative pi over 2 and less than pi over 2. And I'm just leaving myself some space because we're going to multiply in a moment. So we're going to solve this inequality for x. So this is the goal right there. So we do have some fractions involved. I would personally like to clear those. Some people don't mind them, but I find that working with fractions is very tedious. So what I would do is look at the denominator here of 2, then you have a denominator of 3, then a denominator of 2. So the least common denominator is going to be 3 times 2 or 6. So just multiply each part here by 6, and then you can get rid of the fractions and you won't have to deal with them. So basically 6 divided by 2 would be 3. And so you'd have negative 3 pi there. So this is less than. This gets distributed to each guy. So 6 times 2x is 12x. And then plus, you have 6 times 2 pi over 3. So this 6 would cancel with this 3 and give you a 2. 2 times 2 pi is 4 pi. So let me write that there. And then basically, this is less than. 6 would cancel with the 2 and give me a 3. So 3 times pi is 3 pi. At this point, again, if you're trying to isolate x, what I would do is subtract 4 pi away from each part. So let me do that over here. This is going to cancel. On the left, you have a negative 4 pi minus 3 pi. That's negative 7 pi. This is less than. In the middle, you're going to have 12x, which is less than. On the right, you can have 3 pi minus 4 pi. That's negative pi. Again, if you want to isolate x in the middle, just divide each part by 12. So divide by 12, divide by 12, and divide by 12. So this right here is going to cancel. Let me slide down here a little bit. And you're going to have negative 7 pi over 12 on the left. And this is less than x, which is less than negative pi over 12. So this is telling me that my function is going to go through one cycle from negative 7 pi over 12 to negative pi over 12, where negative 7 pi over 12 and negative pi over 12 are my two consecutive vertical asymptotes. And let me come down to this page right here. Let me go back up and let's talk about the period. So what is my period? And then I'm also going to need to know what is my quarter period. So the period, again, if you're looking at y equals the tangent of x, Well, the period is just going to be pi. If I change this to y equals the tangent of bx, well now, provided that b is positive, again, if you don't have a positive b, you could just use absolute value bars, but provided that b is positive, you'd say the period is pi over b. So you're just dividing by whatever the coefficient of x is. So here, we have a coefficient of x that's 2, so the period is pi over 2, and then the quarter period is pi over 2 times a fourth, so that's going to be pi over 8. So this is pi over 8. If you want to know if you got the right period, let's come down here and paste this in and just put a little border around it, you can actually subtract. So you're going to go larger minus smaller, and you should get pi over 2. So negative pi over 12, so that's for this guy right here, and then you're going to go minus this negative 7 pi over 12. Convert this into plus. Minus a negative is plus a positive. So this becomes, you could write negative 1 there. So negative 1 pi plus 7 pi, that's going to be positive 6 pi over 12. And of course, this simplifies to pi over 2. So that confirms the period right there. So you have two consecutive vertical asymptotes. Let me put vertical asymptotes here. You have one at x equals negative 7 pi over 12. And then the other, I'll just put and here, x is equal to negative pi over 12. If you come to the graph, and I have a link for you on Desmos if you want to get something that has more detail. I have all the points labeled for you if you want to click on that. This is what we've found so far. So this is the vertical asymptote, and this is the leftmost one that we found. So x equals negative 7 pi over 12. Again, if you plug that in for x there, you're going to get undefined. So that's why you're getting a vertical asymptote there. Then this guy right here is going to be our x equals negative pi over 12. Again, if you plug that in for x there, you're going to get undefined. So you're getting this vertical asymptote here. Our next goal is to figure out what is this point, and this point. So this is the quarter of the way through, this is halfway or midway, and this is 3/4 of the way through. So let me come back and let's think about how we can use this information. So the first thing is you can find your x values by just adding quarter periods. So you can start with this one, x equals negative 7 pi over 12, add the quarter period of pi over 8, and you just keep doing that to get the next x value and the next x value and the next x value. The y values you can either plug into the function or you can use graphing transformations. So I'll show you both. Let me go ahead and grab this real quick. So you have negative 7 pi over 12 and then plus pi over 8. I'm not going to have enough room to do this on the sheet, so I'm actually going to go to another page. If you're trying to find your x value for the first quarter point, let's multiply this by 3 over 3. And let me slide this down. I'm going to multiply this by 2 over 2, just so we can have a common denominator. If you notice, you have a denominator of 12 and a denominator of 8. So this is basically 2 squared times 3. And this right here is 2 cubed. So basically the LCD is going to be 24. It's going to be 8 times 3. So this right here would turn into negative 14 pi over 24, just multiplying 2 times negative 7 pi, that's negative 14 pi, and then 2 times 12 is 24. And then plus over here, 3 times pi is 3 pi, and this is over 8 times 3, that's 24. So if you do this, negative 14 pi plus 3 pi, that's negative 11 pi, and this is over 24. Okay, let me write this right here. So for my first quarter point, the x value is negative 11 pi over 24. The quarter period, we have that listed as pi over 8, but again, we could see that we could write that as 3 pi over 24, so we have a common denominator. So go ahead and add here. So negative 11 pi over 24 plus 3 pi over 24, that would be negative 8 pi over 24. You can simplify that, but I wouldn't do it yet. Let's come down here. So this is for the halfway or midway. So basically, this is going to be negative 8 pi over 24. And if you simplify that, 24 divided by 8 is going to be 3, and 8 divided by 8 is 1. So this becomes negative pi over 3. Okay, then we want our 3/4 of the way point. So start with this. And again, just add a quarter period. So this is plus 3 pi over 24. And let me slide this down over here. So this should be negative 5 pi over 24. Just doing negative 8 pi plus 3 pi, that's negative 5 pi over the common denominator of 24. So negative 5 pi over 24. Now coming to the graph, we can see that for the first quarter point, the y value is going to be negative 1. For the halfway point, it's going to be positive 1. And then for the 3/4 of the way point, it's going to be 3. Now, how could we get that? Well, essentially, you could plug into the function or you could use graphing transformations. Let me just show you with this one right here that you could do it that way, and then I'll do the graphing transformations because it's a little bit faster. So coming back up here, you would want to say, what is f of negative 11 pi over 24. So you're just plugging in. So this equals 2 times the tangent of, you have 2 times negative 11 pi over 24. You're just plugging this right here in for x right there. So that's all you're doing. And then we'd say plus 2 pi over 3, and then plus 1. You can think about this canceling with this and giving me a 12 down here, and then I could multiply this. Let me scooch this down a little bit. I could multiply this by 4 over 4, so I have a common denominator. So this would be negative 11 pi over 12, and then plus this would be 8 pi over 12. So let me write that in. And then you would have negative 11 pi plus 8 pi, that's negative 3 pi. So you'd have negative 3 pi over 12. Negative 3 pi over 12. And of course, that's going to simplify to negative pi over 4. So negative pi over 4. We know that the tangent of negative pi over 4 is negative 1. So basically, this becomes 2 times negative 1 and then plus 1. So 2 times negative 1 is negative 2, and then negative 2 plus 1 is negative 1. So this equals negative 1. Again, if you go to the graph, you can clearly see the y-coordinate here is negative 1. So let me put negative 1 in right there. Now, what's the other way to do this? Because that's pretty slow. Well, you could have used graphing transformations. In other words, you know that on y equals the tangent of x, you have these points which are for the quarter of the way through, again, it's negative pi over 4, comma negative 1. And then for halfway through, it's going to be 0, 0. That's your x-intercept. And then for 3/4 of the way, you're going to have pi over 4, 1. Well, what's happening in terms of the vertical transformations? Well, you have this 2 out in front. That's giving me a vertical stretch by a factor of 2. And then you have this plus 1 right here, which is going to give me a shift up by 1. This is done first, and this is done second. So in other words, if I take this, let me move this down here a little bit so it fits. So if I take this right here, this y-coordinate of negative 1, and I multiply by 2 first, and then I add 1 second, well, that's negative 1 times 2, that's negative 2, and then negative 2 plus 1, that's negative 1. If I go through this one, and I go 0 times 2 plus 1, well, 0 times 2 is 0, plus 1 is 1, positive 1. And then if I look at this one, I have 1 times 2 plus 1, so 1 times 2 is 2, 2 plus 1 is going to be 3. And that's exactly what we saw. If you look at for the halfway point, well, basically the y-coordinate is 1. If you look at the 3/4 of the way point, the y-coordinate is 3. Once you know those y-coordinates, when you go to the right or to the left to extend the graph, those are always going to be the same. So for the first quarter point, it's always going to be negative 1. For the halfway point, it's always going to be positive 1. For the 3/4 of the way point, it's always going to be positive 3. So you only need to figure out the x coordinates for the vertical asymptotes and for the points that you're getting. And you can just do that by continually adding quarter periods. In other words, in terms of getting the x values, you could start here, add a quarter period, 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 and you would just keep getting to the next guy. So let's come through here and just put that this is 1, and then put that this is 3. So those are your points. Again, you can get more points if you want. That's going to be up to you. I left you a very detailed graph on Desmos where all the points are filled in. But basically, I can come through here and try to fill this in. It's going to be really tight. This point right here, let me just arrow to it and say it's negative 11 pi over 24, and then comma, negative 1. Then you have your negative pi over 3, comma 1. So this right here is negative pi over 3, comma, positive 1. And then this one right here is negative 5 pi over 24, comma 3. So again, you can click that link and go to Desmos and see all of these points. I've labeled them for you if you want to get more detail. All right, before I move on to the next problem, I want to show you this using only graphing transformations. This is something you should be aware of. In some cases, it's faster. You may prefer to do it this way, but generally speaking, it's very error prone because a lot of students have trouble with horizontal transformations. So things that affect the x coordinate. So let's just look at f of x equals 2 tangent of 2x plus 2 pi over 3 and then plus 1 and compare it to your f of x is equal to your tangent of x. So with this one, let me actually grab this real quick and let me come down here and paste this in. You have your basic points, which we already know at this point. Let me put a little border here. The first quarter, so basically that's going to be negative pi over 4, comma negative 1. You have your halfway, that's going to be 0, comma 0. And then you have your 3/4, and basically that's going to be pi over 4, comma 1. So you think about the transformation. So you're going to have a new x coordinate and a new y coordinate. Of course, you also have the asymptotes to consider. So for that, you just have to think about the x. So you'd have x is equal to negative pi over 2. And so you'd have x is equal to pi over 2. And these right here, these are the vertical asymptotes. So let's come back up. And the first thing I would do is I would factor this. So I would say f of x is equal to 2 times the tangent of, pull out that 2 there. It's just going to make the phase shift a lot easier to find. So pull that out, and then you're going to have x plus pi over 3. And basically close that down and say this is plus 1. I always like to check this. So 2 times x is 2x, and then plus 2 times pi over 3 is 2 pi over 3. So that's good to go. So here is where it starts to get a little bit confusing. You have transformations that are happening to the y, those are the vertical transformations, and you have transformations that are happening to the x, those are the horizontal transformations. The vertical transformations are very straightforward. If you have something like a times, let's say, f of x plus b, so let's say g of x is equal to this, we already know that basically this right here is a vertical stretch if a is greater than 1, and it's a vertical compression, or sometimes you'll say a vertical shrink if a is between 0 and 1. Then for this one right here, this b, this is giving me a shift up if b is positive and a shift down if b is negative. So hopefully you know that already. And in terms of the order, we follow just the order of operations. You do multiplication before you do addition in the order of operations. So this is done first and this is done second. So if I look at this is done first and this is done second. So we know that for the y coordinates, again, we saw this earlier, you're going to multiply by 2 first and then you're going to add 1. So if we think about those points, and let me slide this over so this fits. When I go over here and I do my transformation, actually, let me move this to another page because I don't think it's going to fit the way that it is. Basically, you can get the y values. Again, you multiply by 2 first. So negative 1 times 2 is negative 2. Then you add 1. So negative 2 plus 1 is negative 1. And then for this one, 0 times 2 is still 0. Then you add 1, so that's 1. And then for this one, 1 times 2 is 2, plus 1, so that's 3. So that's very straightforward. It's done almost instantly. Now let's come up and let's think about the harder guy, which is going to be what's happening to the x coordinates. Basically, what are the horizontal transformations? We know that if we have something like, let's say g of x is equal to f of, let's go ax here. This is going to be if a is greater than 1, you have a horizontal compression, or you could say a horizontal shrink. And then if a is between 0 and 1, now you're going to have that horizontal stretch. So it's always the opposite of what you think. So basically here, when you think about that 2, well, that's something that's greater than 1. So that is going to give me a horizontal compression, or you could say a horizontal shrink, however you want to say that. Now, this is the confusing part because there's different terminology. Some people will say that there's a horizontal compression by a factor of 2. If you want to say that, that's fine. Typically, I'll say it that way. Other people will say that it's been horizontally shrunk by a factor of 1/2. Whatever you want to use in terms of the terminology, just realize that you're going to either be dividing by 2 or multiplying by 1/2. Whatever you want to do there and whatever you want to say, just realize what's happening. Now, this part right here, this is your phase shift. And again, it's the opposite of what you think. If you have x plus pi over 3, that means that I want to go pi over 3 units to the left. I want to go minus pi over 3. It's always the opposite of what you see. So what you would want to do here is actually do this one first and then this one second. So why is that the case? If we were thinking about the order of operations, then you would want to do what's inside the parentheses first and then what's outside, which in this case would be multiplication, second. But again, on the inside, you have to reverse everything. This looks like I'm multiplying by 2. Well, I have to do the opposite of that. I have to divide by 2. This looks like I'm adding pi over 3. I have to do the opposite of that. I have to subtract pi over 3. And then the same thing happens with the order of operations. It has to go in reverse now. So basically, it has to be this one first and then this one second. So if we think about all the x values, the first thing you're going to do is you're going to multiply by 1/2, or again, you could divide by 2. And that's because you have to undo this part right here. You undo multiplication by 2 by dividing by 2 or multiplying by 1/2. Then the second guy here that you're going to do, you're going to subtract away pi over 3. So you can just write subtract pi over 3, or you could put add negative pi over 3. So this is what we need to do to each x to get those x coordinates. So let me come down here. We'll do it to the asymptotes first. So if you start with negative pi over 2 and you multiply by 1/2 first, that's going to be negative pi over 4. And then in step 2, you're going to take negative pi over 4. You're going to need a common denominator, so let's multiply this by 3 over 3 now. So that would be negative 3 pi over 12. So you can have negative 3 pi over 12, and you're going to subtract away pi over 3. Let's write that as 4 pi over 12, just getting a common denominator. If you do the subtraction, you're going to get negative 7 pi over 12. Notice that matches exactly what we got right here when we solve the problem in a different way. So you get x equals negative 7 pi over 12. The other guy is going to be x equals negative pi over 12. So let me erase this. And then for this one, again, all you're going to do, you're going to multiply by 1/2. So pi over 2 times 1/2, that would give me, let me actually show this. So pi over 2 times 1/2. This would be pi over 4. So that's done first. And then once you have that, you subtract away pi over 3. So you have pi over 4, and then minus pi over 3. Again, get a common denominator. This would be multiplied by 3 over 3. So this would be 3 pi over 12. Multiply this by 4 over 4. So this would be 4 pi over 12. So 3 pi minus 4 pi would be negative pi over the common denominator of 12. So negative pi over 12. Again, as I just told you, x equals negative pi over 12. That's your other vertical asymptote that we found earlier using the other approach. And we'll arrow to this. So the vertical asymptotes here, for this guy, you would have x is equal to negative 7 pi over 12, and then x is equal to, let me put and in there, negative pi over 12. So that's how you could find that using the graphing transformations only. Let me go ahead and copy this real quick, and let me come down here and paste this in. For getting the x coordinates for these 3 points, again, you just follow the same procedure. Multiply by 1/2, then subtract away pi over 3. Negative pi over 4 times 1/2, negative pi over 4 times 1/2, that's going to be negative pi over 8. So once you have that, you're then going to subtract away your pi over 3. So minus pi over 3. We need a common denominator here. That's what makes it take so long. So let's say this is negative 3 pi over 24. Just multiplying this by 3 over 3. And then minus, let's multiply this by 8 over 8. So 8 pi over 24. And we get negative 11 pi over 24. And we know that's the case. So negative 11 pi over 24. Again, if you check with what we did earlier, here's negative 11 pi over 24, comma negative 1. The next one's a little bit easier because you're working with 0. So 0 times 1/2 is still 0. So then you just need to subtract away pi over 3. So this becomes negative pi over 3. And so negative pi over 3, comma 1. Again, here's your halfway point. So negative pi over 3, comma 1. And then for the last one, you have pi over 4 times 1/2. So that's done first. So this would be pi over 8. So then we have to subtract away pi over 3 from that. So you have pi over 8 and then minus pi over 3. Again, just get a common denominator. I'm going to multiply this by 3 over 3. So this is 3 pi over 24. And then minus, you multiply this by 8 over 8. So this is 8 pi over 24. And this gives me negative 5 pi over 24. So this is negative 5 pi. Let me make this 5 better here. Over 24, comma 3. And let me show you that real quick. Here's your negative 5 pi over 24, comma 3 that we found earlier. So of course you can use this approach. Many students like it because it's a little bit faster, but you really have to understand all the different graphing transformations, particularly what's being done to x and what is the correct order. So if you have that down, then you could use this method. In some cases, it's a little bit faster. All right, let's take a look at another example with tangent. So here we have f of x equals the tangent of x over 2 minus 5 pi over 4, and then plus 1. So again, you can use the book procedure, the one that I started out with, or you could use graphing transformations. It's really up to you. I'll do this one both ways again. And then for the ones that we're going to do with cotangent, we'll have 2 examples. I'll just pretty much stick to the book method for those. So let's start off with our book method. Again, you're going to take this right here, the argument for the tangent function, and you're going to say x over 2 minus 5 pi over 4. And you're going to first say that this is greater than negative pi over 2 and less than pi over 2. So your goal is to solve for x. So we want to solve for this guy right here. So what you could do, again, if you have fractions involved, is just clear them first. It just makes your life a lot easier. And so what you see is you have a denominator of 2, 2, 4, and 2. So the least common denominator would be 4. So just multiply everything by 4 here. And let me do that like that and like that. So this 4 would cancel with this 2 and give me a 2. 2 times negative pi is negative 2 pi. So this is less than. 4 would cancel with 2 and give me 2. 2 times x is 2x. And then minus these 4s would cancel. So you have 5 pi. And this is less than 4 would cancel with 2 and give me 2. 2 times pi is 2 pi. Again, if I'm trying to solve for x, what do I do? Well, first, I would add 5 pi to each part. So let's go ahead and do that. And let me move this in a little bit more, like that. So on the left, 5 pi minus 2 pi is going to be 3 pi. So this is less than 2x. Let me show this as canceling, which is less than 2 pi plus 5 pi. That's going to be 7 pi. Again, if you want to isolate x here, just divide each part by 2. So let's go ahead and say this is divided by 2, this is divided by 2, and this is divided by 2. So this would cancel. Let me slide down here a little bit. And so now we have x is greater than 3 pi over 2 and less than 7 pi over 2. And let me come down here to a fresh page. So again, just getting the information for the consecutive vertical asymptotes. So vertical asymptotes, you're going to have x is equal to 3 pi over 2. And then you're going to have x is equal to 7 pi over 2. So if you want to come to the graph, again, I gave you a link for a more detailed version on Desmos. This is your x equals 3 pi over 2. And then this is your x equals 7 pi over 2. So far we have that. But we need these 3 points. Again, you're quarter of the way, halfway, 3/4 of the way. The first thing is we do need the period. So what is the period? Let's go back up. So this right here is x over 2. You could really write that as 1/2 times x. So you could say this is f of x is equal to the tangent of, let me factor this because we're going to do this with all graphing transformations in a little while. So that'll already be done. Let me pull out a 1/2. So inside you'd have x minus. So then for this part right here, if you pull out a 1/2, it would be 5 pi over 2. Close that down, close this down, and then plus 1. Again, if you want to check this, 1/2 times x is 1/2 x, or x over 2 if you want to write it that way. Then you have minus and minus, and then 1/2 times 5 pi over 2 would give me 5 pi over 4. So that checks. All right, so if we look at it now, you have this 1/2 here. So the period is going to be pi divided by 1/2. So pi divided by 1/2, so you can go pi over 1 times 2 over 1, which is 2 pi. Okay, so now we know that the period is 2 pi. And then the quarter period, again, you just divide this by 4 or multiply it by a fourth. We know that 2 pi over 4 would be pi over 2. That's your quarter period. So if you want to get your x values, you're going to start with this 3 pi over 2, and then you're going to add quarter periods. Let me come down here. So let me start with 3 pi over 2, and I'm going to add pi over 2. And then basically that's going to give me 4 pi over 2. So let me write this as the quarter point, so the first quarter. You're going to have 4 pi over 2, if you want to do that now, is going to be 2 pi if you simplify. But keep it like this for adding. So for the next guy, you're going to go 4 pi over 2 plus pi over 2. That way you don't have to worry about getting a common denominator. This will give me 5 pi over 2. So for the halfway point, or the midway as a lot of books say, you have 5 pi over 2 for the x-coordinate. And then we'll do this one more time. So 5 pi over 2, and then plus pi over 2. This is going to be 6 pi over 2, which of course is 3 pi. So let's say that this is the 3/4 point, and basically the x value there would be 3 pi, just doing 6 pi divided by 2. Okay, we don't need this anymore. We have what we want. And basically all you need to do at this point is get your y coordinates. And if we go back to the graph, you can see that this right here is your first quarter, and it's going to be at 0. So you're on the x-axis. Then the midway, or the halfway point, you're going to be at +1 for the y-coordinate. And then for the 3/4 of the way, you're going to have a y-coordinate of 2. So it's going to be 0, 1, and then 2. Now, where is that coming from? Well, basically, you just have this +1 here. That's the only thing you're doing in terms of a vertical transformation. This right here is just a 1, if you want to write it. So basically, all you have to do is take your normal y values, which you get -1, 0, and 1, and just move them up by 1. So in other words, instead of -1, you get 0. Instead of 0, you get 1. And instead of 1, you get 2. This is going to be 0. This is going to be +1. And then this is going to be +2. Again, that's coming from those basic points from the tangent graph. So negative pi over 4 comma -1, your y-coordinate of -1, you add 1, you get to 0. And then your halfway point is 0, 0. Your y-coordinate of 0, you add 1, you get to 1. Then your pi over 4 comma 1, you take that y-coordinate of 1, you add 1, you get to 2. So those are your points for the quarter, half, and 3/4. So you can have 2 pi comma 0. Let me label that. So this right here is 2 pi comma 0. Then this one right here is 5 pi over 2 comma 1. So let me label that one. This one is 5 pi over 2 comma 1. And then this one is 3 pi comma 2. So this one is going to be 3 pi comma 2. Now, in terms of continuing this graph to the left or to the right, remember that for these points, you're always going to have the same y value. So this one, the first quarter point, you're always going to have a y value of 0. For the halfway, you're always going to have a y coordinate of 1. For the 3/4 way, you're always going to have a y coordinate of 2. So that's not going to change. The only thing that's going to change is the x value. And the way you can do this is you can just constantly add if you're going to the right or subtract if you're going to the left quarter periods. That's all you really need to do to find your additional points in your additional vertical asymptotes. Okay, so one more time I'll do this with transformations only. I know a lot of people want to see this because you don't get a chance to really practice this in the book because they don't cover it in most cases. So again, when I think about this, I can put a 1 right here. So really, in terms of a stretch or compression vertically, there's none, right? So basically you have 1 times the tangent of whatever this is, and then plus 1. So there's no vertical stretch or compression. This is just a 1. But you do have this plus 1 on the outside here, which is giving me a shift up by 1 unit. So in terms of the vertical transformations, I know that I'm just going up by 1. Again, if you want to take these right here, and let's slide this down, and compare them to the original points from y equals the tangent of x, let me do this like this. You have negative pi over 4, comma negative 1. You have 0, comma 0. And then you have pi over 4, comma 1. Well, again, all I'm doing is I'm just adding 1 to each y value. So negative 1 goes to 0. 0 goes to 1. 1 goes to 2. So we did that already, but basically that's all we're doing for the vertical transformations. Okay, let me put this right here. And now let's talk about the horizontal. Again, this is the one that's a little bit more confusing. And basically now we have the case where we have this 1/2 here. So remember, if it's between 0 and 1, now you're getting a horizontal stretch. Again, it's always the opposite of what you think. How do you undo multiplication by 1/2 or dividing by 2 if you want to think about it that way? Well, you need to multiply by 2. So the first step here, so step number 1, you're going to multiply by 2. This is going to be horizontally stretched by a factor of 2. And remember, this is going to be what you do first. Then this part right here, this is minus 5 pi over 2. So this is going to be done second. Again, it's the reverse of what you think. So since it's minus 5 pi over 2, I've got to add 5 pi over 2. So I want to shift to the right by 5 pi over 2. So let me put for number 2, this is going to be add 5 pi over 2. So again, if you always remember that things on the inside are the reverse. So basically this is 1/2. So to undo that, I need to multiply by 2. This on the inside is minus 5 pi over 2. To undo that, I need to add 5 pi over 2. And then you even go in the reverse order. So you reverse the order of operations. Normally, you do what's inside of parentheses first, and then you would multiply second. You reverse that order. So you would do this one first, you do the multiplication first, and then you do this part right here, what's inside the parentheses second. So you have to keep everything straight with the horizontal transformations. I know it gets super confusing. So if this is not something that's straight in your mind, I would just go with the other procedure. You could start off with the vertical asymptotes. So just start with your x equals negative pi over 2 and x equals, you could do pi over 2 like this. So these are your vertical asymptotes when you think about the standard y equals tangent of x that you start with. So basically I'm going to multiply by 2 first. So let's go negative pi over 2 times 2. That's going to give me negative pi. And then once I've done that, I want to add 5 pi over 2. So let me start now with negative pi like this, and I'm going to add 5 pi over 2. Well, let's write this as negative 2 pi over 2. And what is that going to give me? Negative 2 pi plus 5 pi, that's 3 pi, and then over the common denominator of 2. So this would go to x is equal to 3 pi over 2. Then for this one, again, you're going to multiply by 2 first. Pi over 2 times 2. Let me show this so nobody's lost. That would give you pi. And then you're going to add 5 pi over 2. So write this as 2 pi over 2. You add that together, you're going to get 7 pi over 2. So this right here is going to become x is equal to 7 pi over 2. Let me put and there. And again, if you go back and check, we found from the other method that x is equal to 3 pi over 2 and x is equal to 7 pi over 2. Those are your vertical asymptotes. Now for the other x values, again, from that first quarter point from y equals tangent of x, you have an x value of negative pi over 4. So you take negative pi over 4, you multiply by 2 first. This would cancel. That gives you 2 down there. So this would be equal to negative pi over 2. And then from there, you're going to add 5 pi over 2. So this would give me 4 pi over 2. And 4 pi over 2 is 2 pi. Again, if you look here, for the first quarter point, you have an x-coordinate of 2 pi. Again, we already figured out that the y-coordinate was 0. Now for the next one, you have an x-coordinate of 0. So you multiply that by 2. I don't even need to show that. That's still 0. And then you add 5 pi over 2. That's going to give you 5 pi over 2. So see, our x-coordinate here is 5 pi over 2 for the midway point. So we just need the last one. So you have pi over 4 for that 3/4 of the way point for the x value. And again, I'm just going to multiply by 2. So this would cancel, give me 2 down there. So now I have pi over 2. And then once I've done that, I'm going to add 5 pi over 2. And this becomes 6 pi over 2, which is 3 pi. So again, you come over here and confirm with what we already did. For the 3/4 point, you're going to get 3 pi for the x value. So that's an alternative approach if you just want to use graphing transformations. As I told you in the last example, I know a lot of students struggle with it, particularly with the horizontal transformations, because everything is the reverse, or you could say counterintuitive to what you think. All right, let's talk about the cotangent function now. So most of you know that the cotangent of x is equal to the cosine of x over the sine of x. So again, just like we saw with our tangent function, the period is pi. You could take this point right here, which is pi over 4, and the cotangent value would be 1. You're dividing square root of 2 over 2 by square root of 2 over 2. This is your cosine value, this is your sine value. The same non-zero number divided by itself would be 1. If you swing around by pi, so if you add pi, and you go to this 5 pi over 4, which is right here, again, you're dividing the same non-zero number by itself. Here you have a negative square root of 2 over 2, and here you have a negative square root of 2 over 2, so you're still going to get 1. And the same thing would be true if you looked at, let's say, 3 pi over 4, and then you looked at 7 pi over 4. Well, here, the cotangent value is negative 1 because you're dividing opposites. So if you swing around, you're going to see the cotangent value is negative 1 there as well at 7 pi over 4. So the period here is going to be pi, again, just like with tangent. When we think about the fact that cosine of x is now in the numerator, well, anywhere where the cosine value is 0, so again, we know that's at pi over 2, 3 pi over 2, 5 pi over 2, or you could go negative pi over 2, negative 3 pi over 2, basically odd multiples of pi over 2, or you can say pi over 2 plus pi n, where n is any integer. That's going to be where the x-intercepts are now. So basically, that's where this is going to be 0, and this will not be 0. So 0 divided by something that's not 0 will give you 0. Then in terms of where it's going to be undefined, well, that's going to be where the sine values are 0, because again, that gives you division by 0. So that's going to be right here at 0, then at pi, then at 2 pi, 3 pi, or you could have negative pi, negative 2 pi. So basically you would say pi n, where n is any integer. Now I have a few basic points here. So just like we saw before. So we have at 0, this guy's undefined. Again, because your sine value is 0. Then at pi over 6, you're going to get square root of 3. At pi over 4, you're going to get 1. At pi over 3, you're going to get square root of 3 over 3. At pi over 2, you're going to get 0. At 2 pi over 3, you're going to get negative square root of 3 over 3. At 3 pi over 4, you're going to get negative 1. At 5 pi over 6, you're going to get negative square root of 3. And then at pi, you're going to get undefined. So we're going to graph this over the interval from 0 to pi, with both of those being excluded, because again, at 0, it's undefined. And at pi, it's undefined. So again, we're going to get vertical asymptotes at those values. All right, let's take a look at a basic sketch of y equals the cotangent of x. Just using these points right here. Again, when you first do the graph of this, you're just going to work from 0 to pi, with both being excluded. So you can see that at an x value of 0, the y value is undefined. Because if you have cotangent of 0, you have the cosine of 0, which is 1, over the sine of 0, which is 0, and 1 divided by 0 is undefined. So that's why you get undefined. Again, as this guy approaches an x value of 0, so coming from the right, as we do this, this guy's going to increase without bound. So it's going to approach positive infinity. Then similarly, for an x value of pi, again, the cosine of pi is negative 1, and the sine of pi is 0. So if I say I want the cotangent of pi, you're setting up the fraction negative 1 over 0, that's going to be undefined. So as your x value approaches pi, coming from the left. So coming from the left, going this way, this is going to decrease without bound. We're going to approach negative infinity. Now, in terms of this stuff in between, you have pi over 6 comma square root of 3. So here's your pi over 6 for the x value. This would be square root of 3 for the y value. So this point right here is pi over 6 comma square root of 3. Then you have your pi over 4 comma 1. So this is one that you want to memorize. That's going to be your first quarter point. We're going to use that. Then you have your pi over 3 comma square root of 3 over 3. So it's going to be this guy right there. Then you have your pi over 2 comma 0. So this is your halfway point. So you need to memorize that one. Then you have your 2 pi over 3 comma negative square root of 3 over 3. So that's this point right here. Then you have your 3 pi over 4 comma negative 1. So that's going to be this point right there. That's going to be 3/4 of the way through. So that's one that you need to memorize. And then lastly, you have this 5 pi over 6 comma negative square root of 3. So that guy right there. So that's your basic points. Usually you just put this point, and this point. You make a vertical asymptote here. You don't need to make one here. You can if you want, but typically you leave that off because this is the y-axis, so you don't draw anything. And basically you just draw this to where it approaches the y-axis and doesn't touch it. And this guy's going to approach this vertical asymptote, which is x equals pi, but not touch it. So that's all you really need to do. So just like with the graph for y equals the tangent of x, when you expand this to the right or to the left, all you're doing is just copying what you previously did. In other words, we graphed this right here, so from 0 to pi with both being excluded, but basically the same thing's going to happen from pi to 2 pi, 2 pi to 3 pi, or if you went this way, you can say from negative pi to 0, you could say from negative 2 pi to negative pi, so on and so forth. So you're going to have a vertical asymptote, you're going to have 3 points, vertical asymptote. So it's just that pattern over and over and over again. And these 3 points, again, the benefit to these guys right here is that basically all you need to know is what is the vertical asymptote here and what is the vertical asymptote here. So I'll show you how to get that in a moment. Once you have this one right here on the left, in this case it would be 0, you just add a quarter period. Well, a quarter of the normal period, the period for cotangent is pi, so a quarter of that is pi over 4. So I know the x value right here is pi over 4. And of course the y value is 1, we can see that. Then this one right here, again, you just add a quarter period. So pi over 4 plus pi over 4, that's 2 pi over 4, or pi over 2, and the y value is 0. Then for this one, again, I'm just adding a quarter period. Let me make that arrow better. So if you have, let's go 2 pi over 4, so we have a common denominator, plus pi over 4, that's going to be 3 pi over 4, comma, negative 1 for the y value. So the y values are things that you want to memorize because typically you're going to do this with graphing transformations. So if you know those y values, it's going to save you a lot of time. You can always plug in if you want to, but I find that to be a very tedious process. For the x values, again, all you're going to have to do is find the vertical asymptotes, figure out the period and the quarter period, and then just go through the process of adding quarter periods to get to the next x value. So I start here, add a quarter period, I get to this x value, add a quarter period, add a quarter period, add an asymptote. Add a quarter period, add a quarter period, add a quarter period, add an asymptote, so on and so forth. All right, let's talk a little bit about the cotangent function in general. So the domain contains all real numbers except for pi n, where n is any integer. So 0, pi, 2 pi, 3 pi, or even negative pi, negative 2 pi. That's where the sign value is 0, and again, division by 0 is undefined. So f of x equals cotangent of x is discontinuous at pi n, where n is any integer, and the graph contains vertical asymptotes at those values. The x-intercepts, so again, this is where the numerator would be 0, and the denominator is not 0, so these are of the form x equals pi over 2. Remember that cosine of pi over 2 is 0, and then plus pi n, where n is any integer. The x-intercept occurs at half of the way between consecutive vertical asymptotes. So if we use that basic y equals cotangent of x over the interval from 0 to pi, both being excluded, this is going to happen at pi over 2 comma 0. So you want to memorize that point. Then the point on the graph 1/4 of the way between consecutive vertical asymptotes has a y-coordinate of 1. So we saw that already. So if you're using y equals cotangent of x over the interval from 0 to pi, with both being excluded, well, you're going to have pi over 4 comma 1. Lastly, the point on the graph 3/4 of the way between consecutive vertical asymptotes has a y-coordinate of negative 1. Again, using y equals cotangent of x over the interval from 0 to pi, with both being excluded, you saw that we had 3 pi over 4 comma negative 1. So again, the period is pi. There are no minimum or maximum values. The range is from negative infinity to positive infinity, and the graph has no amplitude. So the graph is symmetric with respect to the origin. So if you did cotangent of negative x, it's equal to the negative of cotangent of x for all x in the domain. So f of x equals the cotangent of x is an odd function. So just like we saw with tangent, I gave you a little model you can use. It's not going to fit perfectly with every scenario, but we can just adjust it. So we have y equals a cotangent of bx minus c, where b is greater than 0. Again, if b is negative, which you'll see in the future, you can rewrite it using identities. If you need the period, you can just use absolute value bars. It's really not that big of a deal. It won't cause that much concern. So what we would do is say that you're going to take this bx minus c like this, and you're going to find an interval over which you're going to graph it by saying it's greater than 0 and less than pi. And that's coming from the fact that if you have y equals the cotangent of x, well, we said that we're going to go x is greater than 0 and less than pi. So again, all you're doing is you're taking this argument right here, which is the bx minus c, and you're just putting it in that place right there, and you're going to solve for x. That's all you have to do. So basically, once you've done that, you're going to find these two vertical asymptotes. So you could do it as an equation. Bx minus c is equal to 0. So that's for this one. And then bx minus c is equal to pi for this one. And then once you have that, just like with the tangent function, you can figure out what the period is. So it's just going to be pi over b. Let me write that out. So the period is just pi over b. So whatever that is, that coefficient of x, if you end up factoring that out, so if you have something like y equals a cotangent of, let's say we pull the b out because we want to use graphing transformations. Let me move this up so it fits. So then inside you would have x minus c over b, like that. Well, the period is still pi over b. So in this form, it's the coefficient of x. In this form, it's outside of the parentheses. So just keep that in mind. Now, once you have that period, you can just figure out the quarter period. So the quarter period, again, that is just pi over 4b. So just take this and multiply it by a fourth. And once you have that, you take the x value here, you add a quarter period, you're going to get your x value here. So the y coordinate would just be given by a in this form. But again, if you have a shift, you have to consider that as well. You do this multiplication here first by your typical y coordinate for y equals cotangent of x, which in that case is going to be positive 1. And then once you've done that, you need to apply your shift either up or down. This 1/4 point, the y coordinate is a because again, 1 times a would be a. Then at the halfway point, the x-intercept, well, again, I could just add a quarter period to get the x value there. And then for the y value, in this form, it's just going to be 0. But again, if you have a shift up or down, you have to consider that. And then you add another quarter period to get the x value. And then you're going to have your 3/4 point, and the y coordinate is now negative a. Because normally, if you have y equals cotangent of x, 3/4 of the way through, you have that 3 pi over 4 comma negative 1. So if you take that negative 1 and you multiply by a, you get negative a. That's where that's coming from. So just keep this in mind as a general model. And with that being said, let's just go ahead and look at an example. All right, let's take a look at an example now with cotangent. So we have f of x equals the cotangent of x over 2 plus pi over 3. To start things off, I'm just going to go x over 2 plus pi over 3. So that's going to be the argument for the cotangent function there, this guy. And basically, you're going to say that this is greater than 0 and less than pi. So I'm going to get rid of these fractions here. You have a denominator of 2 and a denominator of 3. So what I would do is just multiply both sides by the LCD, which would be 6. So 0 times 6 would still be 0. Let me just show it for right now. Multiply this by 6, multiply this by 6. Let me slide this over here and then multiply this by 6. Let me drop down a little bit. So as I just said, 0 times 6 is still 0. This is less than 6 divided by 2 would be 3. And 3 times x is 3x. And then plus 6 divided by 3 is 2. 2 times pi is 2 pi. And then this is less than 6 times pi is 6 pi. If you want to isolate x in the middle, then what you're going to do is subtract 2 pi away from each part here. Let me just put minus 2 pi here. And so this is going to cancel. We're going to have our 3x in the middle, and this is greater than negative 2 pi. And it's less than 6 pi minus 2 pi would be 4 pi. As a final step here, let me divide each part by 3 just to finish things up. So this is going to cancel. And what you're going to have is that x is greater than negative 2 pi over 3 and less than 4 pi over 3. Let me come down here and just paste this in, and I'll put a little border, and I'm going to say that's my consecutive vertical asymptotes. So vertical asymptotes, you're going to have x is equal to, you have this negative 2 pi over 3, and then let me write that better there. And let me fix this 3 here. We're going to say x is equal to 4 pi over 3. Let me show you this graphically first. So coming down to the graph, you see that you have a vertical asymptote here, and this is our x equals negative 2 pi over 3. And then you have a vertical asymptote here. This is going to be our x equals 4 pi over 3. So that we know, we need to figure out this point, and this point. So let's go back up. So what you want to do is figure out what is the period. And for this, again, let's go up here. When you look at this, you have x over 2. So you can think about that as 1/2 times x. So the standard period is pi. Again, all you're going to do is go pi over 1 divided by 1/2 or times the reciprocal of that, which is 2 over 1. So this is 2 pi for the period. Let's write the period as 2 pi. And then the quarter period, this is going to be 2 pi over 4, which is pi over 2. So again, all you have to do at this point is just go through and say, well, I'm going to go negative 2 pi over 3 plus pi over 2. So just starting at that leftmost vertical asymptote that we found. And you need a common denominator here. So let me actually write this. I'm going to multiply by 3 over 3. And I'm going to put this as, let me scooch this down a little bit so we have some room. This would be 3 pi over 6. So I have a common denominator. And this guy right here I'm going to write as negative 2 pi over 3 times 2 over 2. So this would be negative 4 pi over 6. So I'm just going to start with that. So negative 4 pi over 6 and then plus the quarter period. So that's 3 pi over 6. That's going to give you negative pi over 6. So let me write this on another page. For this one, your first quarter point, you're going to have negative pi over 6. We'll get the y values in a second. I think all of you can see that there's no vertical transformations that are applied. So you could just put 1 now if you want, but I'll just do that separately. So then we have the 1/2, and then we have the 3/4. And let's go up and get those. So I'm going to start now with the negative pi over 6. And I'm just going to keep adding quarter periods. So I'm going to add 3 pi over 6. So this gives me 2 pi over 6. 3 pi minus pi, that's 2 pi. And 2 pi over 6, you can write that as pi over 3. Let's come down here and say this is pi over 3. And then let's do that one more time. So we would want to do 2 pi over 6. So 2 pi over 6 plus the quarter period. We'll write that as 3 pi over 6. So that gives me 5 pi over 6. Let's come down and put 5 pi over 6. Now, for the y values here, again, when you look at these points, you see the y value here is 1, the y value here is 0, and the y value here is negative 1. That perfectly matches what we see with y equals the cotangent of x. And the reason for that is you don't have any vertical transformations here. This you could really put as a 1, so there's no vertical stretch or compression. And out here, you don't have anything. So you could put plus 0 to make that clear. There's no shift up or down. So you would match those y values perfectly. So for the first quarter point, you have a y value of 1. For the midway point, you have a y value of 0. And for the 3/4 of the way point, you have a y value of negative 1. So let's put 1 here. Let's put 0 here. And then negative 1 here. So we're ready to go in terms of labeling those points. You would have negative pi over 6 comma 1. So that's going to be this first point right here. So this is negative pi over 6 comma 1. That 6 could be a lot better. Then we have pi over 3 comma 0. So this one right here, let's say that's pi over 3 comma 0. And then this one, the 3/4 of the way, it's 5 pi over 6 comma negative 1. So this one, we'll say that this is 5 pi over 6. Let me make that 6 a lot better there. And then comma negative 1. So those are your 3 key points. Again, if you want to go to the right or to the left, you just keep adding quarter periods. So in other words, if I take this 5 pi over 6 and I add a quarter period, I'm going to be at 4 pi over 3. And you could just keep doing that to get the next point, the next point, the next point, vertical asymptote. The next point, the next point, the next point, vertical asymptote. The y values are always going to be the same. In other words, for the first quarter point, you're always going to have a y value of 1. For the halfway point or the midway point, you're always going to have a y value of 0. And then for the 3/4 of the way point, you're always going to have a y value of negative 1. All right, let's take a look at another one. So here we have f of x equals 1/2, and then cotangent of, we have 2x plus 2 pi over 3, and then plus 2. All right, so again, I'm just going to take the inside part here, so the argument for the cotangent function, and I'm going to start by saying 2x plus 2 pi over 3 is greater than 0, and it's less than pi. So we'll solve this first. And so let me slide down here just a little bit. I would get rid of this denominator of 3. So just multiply everything by 3. So you would have 0 times 3. Let me show this. So 0 times 3 is less than 2x times 3 plus 2 pi over 3 times 3. And this is going to be less than pi times 3. So 0 times anything is 0. So this is still 0. This is less than. 2x times 3 is 6x. And then plus, these 3's would cancel. So you have 2 pi, so which is less than 3 times pi is 3 pi. So at this point, I'm going to subtract 2 pi away from each part. Let me write that like that. And so this is going to cancel. You're going to have 6x in the middle. So this is greater than, you're going to have negative 2 pi, and less than 3 pi minus 2 pi is pi. To finish things up, let's divide everything by 6. And so that's going to give me this canceling in the middle. So x is greater than, if you think about 2 and 6, well, 2 divided by 2 is 1, and 6 divided by 2 is 3. So let's say this is negative pi over 3. and it's less than pi over 6. So let's grab this. Okay, let me put that in there like that. So again, your two consecutive vertical asymptotes. So vertical asymptotes, you're going to have x is equal to negative pi over 3. And then you're going to have x is equal to pi over 6. All right, so this one's a little bit busy. So again, I've given you a link on Desmos if you want to click that to get more detail. This is your vertical asymptote, which is going to be x equals negative pi over 3. So that guy right there. Then this is the other one. So this is the vertical asymptote. It's x equals pi over 6. So we're going to be finding these 3 points right here. So let's go back to right here. If you want your period, again, it's pi, which is your standard period, divided by 2, the coefficient of x. So it would be pi over 2. So let me write that the period is going to be pi over 2. And then your quarter period, so this is pi over 2 times a fourth. So that's pi over 8. So again, all you have to do is take this negative pi over 3, and you're going to add a quarter period. So you're going to add pi over 8. Now again, you need a common denominator. So let's just go ahead and right now multiply this by 3 over 3, just so that we're not struggling the whole time to get common denominators. So this right here would give me 3 pi over 24. Okay, so let me adjust this. I'm going to write negative pi over 3 as negative 8 pi over 24. And then I'm going to add 3 pi over 24. So then for the first quarter point, the x value would be negative 8 pi plus 3 pi. That's negative 5 pi. And this is over 24. And let me put for the first quarter point, you want negative 5 pi over 24. Okay, so we're going to have halfway and then 3 quarters. We're going to figure those out right now. So let me take this, negative 5 pi over 24, and all I'm going to do is add a quarter period. So let me rewrite that. It didn't take it with it. So plus 3 pi over 24. So negative 5 pi plus 3 pi, that's going to be negative 2 pi over 24. So if you think about that, you can simplify. 24 divided by 2 is 12, and 2 divided by 2 is 1. So this would be negative pi over 12. So this is negative pi over 12. And let me get rid of that. And we only have one more to do. So let me move this over. So let me add 3 pi over 24 one more time. And so negative 2 pi plus 3 pi, that's going to be pi. And this is over 24. So this would be pi over 24. Okay, in terms of the y values, you do have to do a little bit of work here because you do have two transformations that are vertical. So let me start off with these basic points here. So on the y equals cotangent of x, you're going to have your pi over 4, comma 1. Then you're going to have pi over 2, comma 0. And then you're going to have 3 pi over 4, comma negative 1. So we're going to think about how we're going to transform here. Again, in terms of vertical, you have this guy that's done first. This is a multiplication by a half. So that's giving me, you could say, a vertical compression by a factor of 2. Or again, a lot of people like to say it as a vertical shrink by a factor of a half. It's just understanding that you're either going to divide each y value by 2 or you're going to multiply by 1/2. It's the same thing either way. It's just a matter of how you want to say it. This right here, this plus 2, that's going to shift me up by 2 units. So this is done first. This is done second. So the order does matter here. So let me write this out. We're going to, for part 1, multiply by 1/2, or again, you could divide by 2 if you want. And then for part 2, we're going to add 2. So again, this is a vertical compression by a factor of 2. Then you're going to add 2. That's shifting me up by 2 units. Okay, so we're first going to multiply 1 by a half. So 1 times 1/2 would be 1/2. Then I'm going to add 2. So you would have 1/2 plus, for 2, you could write that as 4 over 2. So this would be 5/2. So this is 5/2. All right, for this one right here, you have 0 times a half. That's still 0. Then you add 2. That's going to be 2. And then for this one, you have negative 1 times a half. That's negative 1/2. And then you add 2. So let's add 4 over 2. So this would be 3/2. So that's basically it. Just a matter of understanding those graphing transformations. Again, if you get confused by that, you can always plug in. So you could always take negative 5 pi over 24, plug into the original function, you'll get 5/2. You could plug in negative pi over 12, you'll get 2. You could plug in pi over 24, you'll get 3/2. All right, let me get rid of this. And let's just label things and we'll be done. So for this one right here, you have negative 5 pi over 24, comma 5/2. So that's going to be this one right here. So this is negative 5 pi over 24, comma 5/2. And if you look at this, it's hard to see, but this notch right here is 2. So this notch right here would be 2.5 because this notch right here is 3. And then if you look at this one right here, that's going to be negative pi over 12 comma 2. So that is negative pi over 12 comma 2. And again, this notch right here is 2. It's covered up by that point. And then if you look at this one right here, we're going to have pi over 24 comma 3 halves. So this is pi over 24 comma 3 halves. And again, this notch right here is 1. This notch is 2. So this is halfway. So that's 1.5 or 3 halves in terms of your y value. So you can see that does match up. Again, if you want to click the link on Desmos, you can see I've labeled all of these points for you so you can go through there and you can get some additional practice by basically just adding quarter periods to this guy. So to the x values here, you'll get your vertical asymptote, and then you're going to get the x coordinates for this guy, this guy, this guy, vertical asymptote, this guy, this guy, this guy, vertical asymptote, so on and so forth. You know the y values are always going to be the same. So for the first quarter point, you're going to have 5 halves. Then for the midway point, you're going to have 2. Then for the 3/4 of the way point, you're going to have 3 halves, so on and so forth. So if you want to play around with it and get some additional points going on your graph, going to the right and to the left, it'll be good to get some practice.